In this video, I will be reviewing the very first lecture of UC Davis Chemistry 130A Pharmaceutical Chemistry 1. The course is taught by Dr. Bill, and here's a course description. This class will provide an introduction to the chemical principles behind the design and production of pharmaceutical agent. Pharmaceutical agents. Okay. Textbook will be using the organic chemistry of drug design and drug action, the third edition, chapters from 1 through 9, and the course is evaluated with 3 quizzes, 20 points each, and a midterm and a final. An overall learning object: how do we take a lead organic molecule and turn it into a drug? And here the very first thing is changing the properties. How do we change the properties of the organic molecule? Hydrophobicity is one of them. Non-covalent interactions. Acidity. Flexibility. And lastly, metabolism. And secondly, how do we expect our changes to work? Here, one more thing, these are all from ochem. So I'm going to have a short ochem preview what I'm supposed to know by the end. How changes work. So why do we expect our changes to work? The very first thing again here is the organic chemistry. We can predict how the changes work. And knowledge of the target drug. This is biochem. And lastly, other off-target issues. This will be taught from the pharmaceutical chem. And how do we evaluate the changes? Are they working or not? And this is biochemical and biology assays. Computational information. And clinical trials. And here's a little bit of the ochem review. We shall know the functional groups and how they work. Here's an example of carboxyl and a hydroxyl group. So if you compare them, they're both polar and they're both soluble in water, and they also lose a proton in acid-base reaction. This is relatively stronger acid, so these were the commons, and here relatively stronger acid and relatively weaker acid. And also they differ by the physiological pH and pKa of the molecule will be determined by either the carboxyl group or hydroxyl group. And also from ochem we shall know the basic nomenclatures. Is it E or Z? We also talk about the mechanisms. With the view of enzymes and intermediates. These are especially covered in chapter 4 and 5. We'll be talking about hydrophilic versus hydrophobic. Intermolecular forces. H-bond, van der Waals, sigma and pi bond, and in a view of kinetics, how many kilocalories per mole they create. And lastly, we'll be answering how to take a lead organic molecule and turn it into a drug. And how do you change the properties of the molecule? So this is the main theme of the pharmaceutical chemistry.